The next kind of transformation I'm sure that you're also familiar with. I mean, a quick example would be, think about the difference between these two graphs. You remember last year what this one looks like. It's the parabola that opens up. This one is the parabola that opens down. What's the difference? That negative sign. We call that a reflection. All right, so we're going to look at two kinds of reflections. The graph can be reflected in the x-axis or the y-axis. And when we say in, we really mean over. I'm not sure why the term in is used, but it's over the x-axis or over the y-axis. Okay? If the negative is outside of the function, like it was in the example I just gave you with the x squared, then the image of the graph of y equals f of x after a reflection over the x-axis. What happens? Well, the point xy becomes the point x negative y. Okay, so let's take an example of that. Here is f of x. It's this point right here, negative 4, 3. What happens when we put a negative in front of it? Well, that graph, it's going to flip which value? It's going to flip the y value. Okay, so it would become this point down here. So what does it negative in front of the function do? It affects the y value. It's outside the function, affects the y. Okay, the other kind of reflection is if we have the negative inside the function. So it's attached to the x. If it's attached to the x, it's going to be a reflection over the y-axis, and it's going to affect the x value. Okay, so take a look here. If we have this graph and we put a negative inside, then what changes? It affects the x value. The x value changes sign, not the y value. Okay? So looking at these two examples, if we put a negative outside, then we can use the word flip, we can use the word reflect. Okay, so what happens? This graph is obtained by reflecting the y values. Okay, or if you don't like that expression, you can say flipping the y values. It doesn't matter. Whatever you choose to say, what we're doing is we're taking the y values and reflecting them over the x-axis. Okay? On the other hand, if we put a negative inside the function, we're either going to reflect the x values. Okay, and again, if you don't like that, you can say flipping the x values, and you could say over the y-axis. Okay, there's lots of ways to say that. So let's try one here. Reflecting over the x-axis. Again, sometimes we say reflecting in the x-axis. Okay, what does it look like? It looks like this. There's a negative outside the function. So over this x-axis. Okay, and so what you're going to do is, some of you will be able to visualize this really nicely, but I always, I visualize a couple of points, and I'm going to flip those points over the x-axis. So this one would stay, this one would stay, this one would stay, but this one would go over the x-axis and it would end up over here. This one would go over the x-axis and it would end up over here. And then if I connect the dots, it's like that. Okay, now on your exam, a lot of times what they do is they give you that first graph and then they'll give you another graph, and the original is very lightly penciled in like that, and then you would reflect using that second graph. Okay, let's try another one. Again, what's going on here? This is outside, so it affects the y values. So let's take a look at the y values at each of these sort of critical points. This y value would go down here. This y value would go down here. This y value, if I flip it over the x-axis, stays. and then I get something like this. So my graph is going to look like this. Okay, let's try a few reflecting over the y-axis. Okay, so reflecting over the y-axis affects the x. So what I would do is again, let's look at some important points here. And I'm going to take the x value and flip it. So this x value would go way over here. Okay, this x value would go over here. This x value would stay. And then go like that, and like that. So I'd have a graph that looks something like that. Okay, let's try this one. Again, I like taking the points and actually flipping them. And I like doing it on the same graph. So as I mentioned earlier, you know, on your exam, you might see this. So it gives you the same graph and you're supposed to reflect those. So let's put this here. This one would go here, and here, and here, and then here. And you have this. Okay. Notice these don't have any value. So let's, you know, for example, if this was -3, 0, then I would expect you to write over here that this is 3, 0 now. But since it doesn't give you the values, we're not going to write them in. Okay, let's try here. The graph of y equals g of x is given. So this graph is g of x. Okay, and I'm going to put in a couple of dots here because I know these are the points I'm going to be changing. So let's look at this graph first. This is y equals negative g of x. This is a negative outside the function, so it's going to affect the y values. So if it affects the y values, it's going to flip over the x-axis. Okay, so something like so. This is negative g of x. Okay, it says state the domain and range of each function. All right, let's state the domain and range of this. What is the domain? The domain is from -3 to 5. And what is the range? The range is from -2 to 3. Okay, let's try this one now. So this time it affects the x values. So if it affects the x, it's going to flip over the y. So this one would come here. This one would come here. This one would move over there. And this one would move over here. So we get this graph. Okay, so that's g of negative x. And what's the domain? The domain is -5 to 3, and the range is -2 to 3. By the way, you're not going to see that in your textbook, so let's write this in another way. How do I write from -5 to 3? Okay, we're going to say x such that. Okay, that's what that means. And we're going to say that x is between -5 and 3. Okay, now I think in your textbook you're just going to see this part, but this is the correct way of doing it. And then what would the range be? It would be y such that, and I want to put y in between -2 and 3. So like that. All right. Same question, different graph. So let's put a couple of significant points here. And we're going to change those. So the first one is negative g of x. This means we affect the y. The y values will flip. So this one, 1, 2, 3, 4, 5, 6, 7, would become 1, 2, 3, 4, 5, 6. So it would come up there. This would go here. This one would stay the same. This one would go right here. Notice the x values are not changing. they are exactly in the same spot. Okay, so I'm going to have a graph that looks something like this. Okay, what is the domain? The domain is negative infinity to infinity, and the range is negative infinity to infinity. Let's try this one. By the way, when we do video lessons like this, whenever I say let's try it, that means you should pause and try it yourself, and then come see if you've done it correctly. So this one affects the x, so the x will flip or reflect. Okay, and so we get something like that. Okay, domain and range, this is a pretty easy one. Just negative infinity to infinity. All right, this is an interesting question, and for some reason these questions on your homework, on your tests, they cause quite a bit of grief. So let's make sure we explain this fairly well. So it says the graph of this is a reciprocal function. It says was reflected over the x-axis. So it's flipped like this, okay, over the x-axis. And the image is shown. Okay, so this graph, where was it before it was flipped? Okay, before it did this, where was it? Well, we could draw it. Okay, it would be something like this. Okay, but it doesn't ask us for that. It says, what is the equation of the image? Okay, so let's make sure we understand that. This one was the original graph, right? But it says its image is shown. Oh, that's kind of an ugly graph I drew. See if I can make it look a little bit better. Not much, but you get the idea. So what is the graph after I reflect it over the x-axis? Well, I don't expect you to look at this and try to figure out the equation. I just expect you to take this equation right here and reflect it. What kind of reflection? Well, if it's over the x-axis, it is affecting the y. So if it's affecting the y, how do I make the y affected here? Okay, it's actually pretty simple. I would do this. I would write the original equation, and if I want to affect the y, I would put a negative outside the function. Okay, it's that easy. If you want to, I'm going to write here, affect the y, okay, or if you want to call it reflect over x-axis, all you do is you put brackets and a negative in front. Okay, this is the image equation, the equation of the image. Okay, so let's write that. All right, now let's try it a little bit different. Let's say the question didn't say that it reflected over the x-axis. Let's say it said reflected over the y-axis. Okay, now just look at this graph for a second. We're talking about this one here. If I reflect that over the y-axis, what is it going to look like? It's actually the same graph, right? If I take, this point would say the same. If I take this one and move it over here, they're the same. It's the same graph. Okay, so how would this equation look? Here is the original equation. And if I want to affect the x, so I'm going to put the same language here. Affect the x, and if I want to reflect over y-axis, I have to affect the x. So everywhere you see an x Instead of writing an x, I'm going to write a negative x. Okay, so here is the x. And instead of putting x there, I'm going to put negative x. Okay, that's all you have to do. So let's review. If I want to affect the y, I'm going to put the negative outside. If I want to affect the x, I'm going to put the negative inside. Attach it to the x. Okay, now your textbook will probably simplify these. You don't have to simplify them. Okay, I mean, if you looked at this simplified, if you put that negative inside, you would have an equation like this. You could put the negative in the bottom, it would turn this one positive, and it would turn this one positive. Okay, but again, you don't need to do that. You don't need to simplify it. If I wanted to simplify this one, it would become 1 over, and a negative x squared, it would just become negative 2x squared minus 0.5, which you can see is the same equation that we started with. Okay? By the way, don't get tricked. You wouldn't cancel these two negatives out, right? Because this negative is canceled by the squared. Okay, so let me just re-emphasize a couple things there. You don't need to simplify. In fact, for grade 12, you don't need to simplify anything unless it asks you to simplify. Okay, please keep that in mind. All right, there's your homework for this lesson.